Today is a majestic era where we live in a world revolving around AI and robotic developments. With weekly progress, new discoveries, and wise inventions, we'd move on to a lesser struggle and hassle in doing work where we might end up relaxing the whole day and letting robots do all the work. Welcome to another video in the Technology Zone. Don't forget to subscribe to our channel, hit that notification bell icon, and like this video if you enjoy watching it till the end. This is the quadruped robot. These robots are inspired by ants who work in cooperation with others to overcome obstacles. When a hunting ant reaches a gap that's too wide for it to cross alone, it will then call on the other ants to form a bridge out of linked bodies from them. Now, this observation has been imitated through a tiny four-legged robot, which may point to a direction of better developments in search and rescue robots. Quadruped robots have many overviewed advantages like their ability to walk around and over an obstacle when traveling through complex and rough terrain. As a result, combined swarms of the quadruped robot are anticipated to be applied in activities like locating survivors at disaster sites. Steep pathways or impediments that are too difficult to climb can prevent legged robots from moving forward. With these limitations, Assistant Professor Yasmin Olskan-Aden of the University of Notre Dame invented a group of 3D printed four-legged robots that can cooperate with each other to conquer them. Each of these is sized 15 to 20 centimeters, 6 to 8 inches long, and has a lithium polymer battery, a microprocessor, a front-mounted light sensor, and one front-mounted and one rear-mounted magnetic touch sensor. When the robot encounters an obstacle like wooden blocks attached to a board, it sends a wireless signal to the neighboring robots. Olskan-Aden focused on improving the sensitivity, battery capacity, capabilities, and collaboration of the swarm robot system. In the future, this robotic system can be applied to other inventive activities such as environmental monitoring, space exploration, and researching more about the dynamics of other insects to add to the search and rescue operations. Next is a dragonfly drone, or the so-called Dragonfly Eye. Scientists managed to transform a genetically built dragonfly into a drone just by attaching an electrical backpack to them. At some point, scaling down machines become difficult. There's just so much a drone can do. Draper researchers have come up with a way to produce a drone out of a dragonfly. Researchers at the Howard Hughes Medical Institute, or HHMI, genetically altered the nerve terminals of a dragonfly's spinal cord. The dragonfly may then be controlled remotely thanks to a backpack that is charged by a small solar panel. The use of flashlights gives the fly direction on where to go. This experiment is not, in any way, dangerous to dragonflies as, according to entomologists, insects don't feel the same pain as humans feel. These strategies certainly have meaningful benefits, like farmers utilizing to monitor the farm, and even this can be used to monitor beehives' health. This can also become a cyborg insect that does surveillance in the near future. Our third is a small cockroach robot. This small insect robot might be the future of disaster search and rescue operations. Some of the best robots have been influenced by nature. Engineers have developed a scurrying bot based on the common cockroach that has roughly the same speed and squish ability as its organic cousin. The delicate robot, which is roughly the size of a postage stamp and can travel at a rate of 20 body lengths per second and endure 1,000,000 times its weight, has yet to be named. In strain, the bot, which weighs less than 100 of a gram, can withstand being stamped on by a 60-kilogram human foot. It just gets up and continues on its day. According to Li Wei Lin, a mechanical engineer at the University of California, Berkeley, most bots of this size are frail. The robot will be destroyed if you step on them. The robot's toughness is attributed to its simple design. It's constructed of a thin sheet of PVDF, or polyvinylidene difluoride, which is a piezoelectric substance that expands and contracts when a little AC power is applied to it. Because of this expansion and contraction, roach bots may move. The researchers were able to bend the sheets in a way that propels them forward to vary the running pace of their concepts by putting a front leg and an elastic polymer layer. Scientists tried different robot lengths from 10 to 30 millimeters, frequencies, voltages, and electric currents. For example, a 20 volts at 850 Hz given to a 10 millimeter robot can scoot down with it. Chinese researchers created a miniature robot that can crawl into tunnels and carry objects up to 6 times its own weight. Currently, the bot needs a power supply, but in the future, this could run on a tiny battery. Small bots might help by assessing disaster sites that are potentially dangerous and unstable. The company is looking at incorporating a gas sensor into the original design, which would allow the robot to enter extremely tight spaces and detect any gas leaks that may be life-threatening. One of the improvements designers want to implement to their tender robot is to find out how to have it avoid obstructions automatically while it explores the planet. Then there are cyborg beetles, which are genuine insects operated by six-legged robots. The future is approaching us. By electrically manipulating the motor activity of live beetles, Dr. Sato, an aeronautical engineer from Nanyang Technological University, met with the motherboard in Singapore. They can be turned into cyborgs by Sato and his team. According to the researchers, beetles are connected in such a way that they'll be operated by a switchboard. Researchers were able to adjust various walking gaits, rates, directions, and other types of mobility after examining their muscular architecture, neural networks, and leg coordination. Furthermore, changing beetles into cyborgs doesn't really appear to be harmful to them in this way. Their usual lifespan is 3 to 6 months, yet even with the researchers interfering, they can live for several months. According to scientists, no beetle has ever died after being aroused. While this technique might look ridiculous, the implications are very real. Sensors that detect heat and thus individuals might be placed in beetles, driving it to creep towards people when they're seeking someone, just like in a police investigation or chasing down a terrorist. The researchers are dedicated to ensuring that any applications this innovation might well have are benign, and who knows how far it may go. It may be used for bigger creatures after such success in affecting the motor processes of beings as tiny as beetles. This robo replica dragonfly comes next. Insects flap their wings quicker than dragonflies. Plagiarizing Mother Nature's homework, no matter how great our human creations are, isn't a terrible notion because evolution has quite a 4 billion year massive advantage. Engineers at the University of Bristol have created a little flying robot with a novel electrostatic zipping mechanism that spreads its wings more successfully than an insect. Drones inspired by birds and insects have indeed been flying for years, including Harwood's ROBO and the Delphi Nimble. While they may do remarkable aerial maneuvers, they typically require complex transmission systems like gears and motors to fly. The Bristol team's new drone uses a liquefied amplified zipping actuator, or LAZA, an artificial muscle technology that does not need transmissions. Each of the dragonfly-sized drone wings is made up of 2 little electrodes with an electrode extending from the base. A high voltage is applied to each of the base electrodes in an alternating sequence, drawing the wings electrode to each one. A flapping motion is formed if we do it fast enough, which is amplified by a liquid dielectric between the electrodes. We use the LAZA to send electrostatic forces straight to the wings rather than using a complex, inefficient transmission system, according to Tim, the study's lead author. This enhances performance and reduces design, paving the way for the creation of a new class of low-cost, lightweight flapping micro-air vehicles for potential developments, including autonomous inspection of offshore wind farms. It could travel at a pace of 2.5 kilometers per hour or 18 body lengths per second across a room. The LAZA technology, according to the researchers, might eventually lead to smaller, more agile drones that can be used for monitoring systems, explorations, search and rescue, or even plant pollination. The quadruped Arduino spider robot will be the next. Arduino performed this work in just 7 days, spending 2 days on the hardware and assembling and 5 days on the programming and Android app. Because these devices are so expensive on the website, This guide offers sufficient documents and code to help you quickly build your crawler. This step-by-step introduction will assist you in making your spider ball. The robot is a crude representation of spider motions, as its name implies. However, since we are only using 4 legs rather than just 8, it will not perform the same physical movements. This robot is also recognized as quadruped robot since the robot has 4 limbs and travels with all of them. To identify the robot's body position and control its body balance, each leg's motion is connected to the motion of the other legs. Legged robots are much more versatile and animalistic than wheel robots when it comes to terrain management. However, since it is dependent on servo motors, this complicates legged robots and makes them less affordable for many people. Also, these are far more pricey than DC motors, which might be utilized in real robots because 4 legs enable passive stability, or the ability to stay up without proactively adjusting posture. The costs of production and high defenses that a company should spend to build a full-body quadruped are expectedly high. In nature, quadrupeds abound, and robots are no exception. A 4-legged bot is affordable and easier to construct than a robot with more legs, but it still maintains stability. Although the term servo motor is normally used to refer to a motor suitable for a closed-loop control system, it is also used here. The output voltage level is between 2.5 and 10 volts, with a typical low voltage of 3 volts, and the output ranges from -40 millivolts to 0 volts. The entire system is controlled in an Arduino Nano, and they've added a robotic spider form to make the robot look a lot better. The Android app connects to your robot via Bluetooth and allows you to go forward, backward, left, and right. It also allows you to adjust the color of the robot in actual time by using a color wheel to choose the color. After uploading the code, link the OLED display to see the stellar robot smiles built in the main code. The Scorpion, a biomimetic crawling robot, is the next robot. The Scorpion is an 8-legged crawling robot that was created for hazardous outdoor areas. It has the ability to travel to locations in which other robots are having problems. It makes use of a biometric control system to allow for exceptionally flexible and steady walking. The Scorpion robot's movement gates are based on research into the motion patterns of real scorpions, with a graphical user interface and voice control as an alternative. Direct control of the Scorpion is possible. The robot can adapt to a range of terrains and barriers using proven biological motor system models. Exploration of dangerous locations like in SAR missions could be a future application. At NASA's Ames research facility, the Scorpion is currently being developed as an amphibious form. The advantages of legged robots for interplanetary trips are being evaluated using a replica of the Scorpion. Finally, there's FESTO, a robotic butterfly, an e-motion butterfly. E-motion butterflies were created by a German company. A drone is a terminology for a robot butterfly, and this butterfly is actually a drone. In contrast to the device with 4 propellers, the capacity to fly is obtained by flapping the wings like a genuine insect, which is highly distinctive. Such skills are used by FESTO to demonstrate not only the capacity of a synchronized robot to multi-fly, but also the possibility of compressing in a lightweight structure. Infrared cameras identify their position, and the information is used to manage each butterfly's movement. These flying vehicles are extremely light, measuring only 32 grams. The wing formations are carbon fiber rods, and the cores are laser fused. 2 tiny servo motors are installed in the base and every wing. The electronics consist of a CPU, an inertial sensor such as a gyro, accelerometer, compass, and 2 radio modules. The flight lasts approximately 3 to 4 minutes. And that is all for our daily updates on the latest futuristic technologies and robots. Next time, we'll bring you even more interesting robot news. So subscribe to our channel, Technology Zone, to stay up to date with us. If you find this video informative and fascinating, you can visit our channel to see more videos like it.